In this video, we're going to be discussing how to calculate the intercepts for a given function. So before we get to the actual calculations, let's review what the intercepts are. So in a coordinate plane here, we have the x and the y axis. Now, when we're looking at functions, one of the key features that we want to find a lot of times is what's called the x-intercept. Fix that. We have the x-intercept, and we have this thing called the y-intercept. So these are typically things that we want to find because they're useful in different applications. So the x-intercept a lot of times is used for solving a problem, looking for these solutions, and the y-intercept is another key feature when we're creating the graph. So the x-intercept is simply when it crosses the x-axis. Now I want to note that that means it's on this x-axis, and every y value on this point is 3, 0. And across the entire way, every x-intercept has a y value of 0. Now the same thing is true for the y-axis, just a flip version. So here I have this point here is the point 0, 2. So my y-intercept, all of the x values are 0. Now, these two facts are going to be really useful when we are calculating the x-intercept and the y-intercept. It's actually how we're going to do it. So let's look at some examples here. So here are some functions, and I'm going to calculate the x-intercepts. So the x-intercepts, that means all of our y values equal 0. So what I'm going to do here is I'm going to replace all of the y's with 0 and then solve. Now in this particular notation here, when I have f of x, that just replaces the y. So to find my x-intercept, I'm going to start by setting this equal to 0. And then solving. So I'm going to have to factor this polynomial. So I have 0 equals x plus 2 times x plus 3. And I'll set each one equal to 0. And x plus 3 equals 0. So I've got x equals -2 and x equals -3. So for this particular graph, my x-intercepts are the points -2, 0 and -3, 0. Okay, so let's do the next one. Let me change colors here. So this is a rational function. So again, I'm going to replace the y with 0. And I'm going to solve this over x plus 3. So to solve this rational function, I'm going to multiply both sides by x plus 3. And what that's going to do is it's going to get rid of this x plus 3 in the denominator. So I'm left with 0 equals x plus 2. So then I go ahead and solve it. So I subtract 2, so I have x equals -2 is my x-intercept. So I have -2, 0. Okay, so this one is a little trickier. So I've got x minus 2 plus 5 all under roll. So what I'm going to do is I'm going to set it equal to 0. So I have the square root of x minus 2. Actually, let's change this. Let's just take plus 5 on the outside. Make it a little bit more interesting. So I've got this particular graph here. Now what I'm going to do is I'm going to bring the negative over. So I'm going to subtract 5 from both sides. So square root of x minus 2. Well, then I'm going to go ahead and square this. So here I'm going to have 25 equals x minus 2. And then when I go ahead and add, I get 27 equals x. Now, here's a little catch, though, when I'm looking at this particular graph. If I go to the graph of this, I don't actually have an x-intercept. Let me show you. So here I have a picture of the graph of what we just talked about. Now, we found in our algebraic examination that we should have an x-intercept at the point 27, 0. Now, here's the problem. When I zoom out here and I look at 27, 0, this doesn't cross the graph. So we could be wondering, what did we do wrong to make this incorrect? Well, let me show you. So when we're looking back at our work here, there's one little catch that maybe you didn't notice. That while I'm working here, we get an odd statement. we get the statement of -5 equals the square root of x minus 2. Now, in this case, that's never going to happen because in this case, the square root is defined as a positive. So what we're saying right here is that a positive square root is going to equal a negative number, which isn't possible. So in this case, there is no x-intercept. So even though we did it algebraically correctly, this actually doesn't have an x-intercept. So we tried our best, but it doesn't work. So you may sometimes have to check and make sure that your work halfway through makes sense. Does a positive square root equal a negative number? Well, no. So graphically, we may want to check that we did this right. Now let's continue on. Let's look at finding the y-intercept. So our y-intercept is the same thing. What we're going to do is we're going to set x equal to 0 and then work it out. So this one's a little bit easier in my opinion, and we're going to edit this again. We'll have it as the 5 on the outside. So we're going to plug in the x, so we'll have y equals, and you can put f of 0, whichever one works for you. So just replace the x's, so plus 5 times 0 plus 6. So I get a y-intercept of 6. So this is the point 0, 6. So there's our y-intercept. Same thing for here. Let's change colors. So we're going to replace the x. So we'll have y equals 0 plus 2 over 0 plus 3. So we get the point 0, 2/3. Okay, those just cancel out. We get 2/3. There's our y-intercept. And the last one we're going to replace. So again, let me rewrite it. We're going to do square root of x minus 2. We'll put the plus 5 on the outside. Otherwise, it's kind of boring. So let's plug in our 0 again. So here I'm going to have y equals the square root of 0 minus 2 plus 5. And so when I do this, I get y equals the square root of -2 plus 5. Now, if you remember dealing with square roots before, we have square root of a negative. That's going to involve the imaginary plane. So this is not defined in the reals. So when we get an example like this, where I have a square root of a negative number, we are going to say no y-intercepts. And this is no y-intercepts in the real plane. If we want to get into the complex numbers, we could, but this has no y-intercept. So to find our x-intercept, let's review. We plug in 0 for y, and we do our calculations. Same thing for the y-intercept. We plug in x equals 0 and work it out.